Hello everyone, welcome to the Azure DevOps Bootcamp. This is Lakshit Pant, your host for today, and it's the day 6 of Azure DevOps Bootcamp. And so far, it's been a great journey with you all, and I hope you have got some incredible insight. I was seeing the feedbacks on the MSI platform that those was incredible, and you guys are. I'm really appreciate you guys are onto something, building something really quick with all these hands-on labs. So just to summarize, we have so far covered the basics of DevOps, source code management with Azure DevOps. Then we have also covered the pipeline as a code with YAML and Azure DevOps on the day third. Then Jay Kumar sir came and he tried to explain how you can automate your DevOps using Azure function. And then it's all about yesterday, where Mubin has explained you everything about in a very detailed manner. He has given his insights around how IAC with resource ARM could really help you build or automate, or maybe to give you as a the session and everything. So this is what we have covered, and today we will talk about containerization you with Azure Container Registry and AKS. And AKS has been the really game changer in the and containers has been really the game changer in the cloud market. So this is going to be really important topic for you all, and I hope you will enjoy the session. And just giving a quick intro about the expert speaker, Mubin Girij. He is a senior DevOps and cloud engineer from IFI Tech Solutions, and he has done some really incredible contributions with us as a part of Azure developer community. So not wasting much more time, we have already past 15 minutes. So I'll quickly, pass on the stage to Mubin. So over to you.
Okay, thanks for the intro. So, hello everyone, I am Mubin Giraj, and today we are going to see how containerization works with ACR and AKS. So, yeah, I will start with my presentation. Just allow me a moment. Okay. So, before actually starting with this presentation on containerization, I will just like to have your idea, your thought on this particular thing. Like, what do you understand when anybody says like, okay, containerization, or anybody says Kubernetes? So, what comes to your mind? I just want to know about that first. Lakshit, the chat is open, right?
So we have something coming like images, pods, clusters already.
Yeah, I think I'm not able to see it. Uh,
So it's, if you will see, I'm just trying to pass on everything on the comment section. We have two comments right over there, images and clustered pods. Someone is saying images, someone is saying cluster and pods.
okay,
Like if
okay,
you will be able to say these.
okay, okay. Yeah, getting it right. Cool. Okay. Anything else apart from clusters, pods, images? Anything else is coming into your mind when we talk about, or when we say about containerization, ACR, AKS? Okay, I have heard Hotstar using AKS. Okay, okay. What else? Anybody heard about Amazon Prime using AKS or Netflix using AKS? Okay, so I think learning DevOps for the first time. Okay, okay, cool. So no issues. You all were somewhere down the line, right? Containerization is all about, you know, pods. You have your containers, you have your images, and for orchestration purposes, we use Kubernetes cluster as well. So now, as you all have, some idea about, what are containers, or we require images for running those containers, and we also require Kubernetes for orchestrating those containers. So I will just start with why containers. Okay, because there has to be some kind of unique points, or some kind of features that containers offers right now, through which we could have a kind of justification that okay, if we are having something else, we are not using containers, then why should we move to containers, right? So the very first point over here is its portability. Okay, so you can just run containers wherever Docker is supported. Okay, so that is the first and foremost point and very important point over here. And I will just explain a bit about this particular point over here, about the portability part. Okay, yeah. So what happens exactly is, now why the Docker is called as a kind of portable platform. Just a minute. Okay, so now we are understanding why is Docker portable. So the thing is that usually the traditional way is that you have some files with you, and then those files may be of PHP, maybe of Node, maybe of Python. Okay, and these are the files of your web application, you can say. And then what you do is you just have your virtual machine, or you can say your local host or your local system. So while you are developing the web application on your local host, so you just install all the dependencies for it, right? Just tell me in the comments if anybody has used XAMPP, or anybody has just hosted their Flask web server on their local host, or somebody has used Apache, or somebody has used NPM and hosted their web application onto the local system. Just give me some kind of heads up in the chat. Nobody has hosted their web application on localhost on their personal system. Something like hello world is also fine, but I just want to know like whether you have hosted your web application anytime on your personal system. Okay, you have hosted your portfolio website. Okay, great. Live server. Okay, okay. So what happens exactly is that before developing any of the websites, PHP, be it Node, be it Python, be it a tech stack. So first and foremost thing that you guys have to do is you have to basically install something. Okay, so that something could be your PHP, that something could be your Python, that something could be your Node. Okay, so it's a kind of prerequisite over here that you need to have any tech stack on which you want to develop your web application, that should be installed onto your system, right? Without it being installed, even if you write something like index.php, you can very well create a file with index.php, but after creating this particular thing, index.php file, or let's say app.py file, or let's say package.js file, you don't have anything, any runtime, or you can say any kind of technology or platform that could just make this index.php your index page of the website, or nothing that could make your local host a kind of web server. Okay, So you need to install these tech stacks onto your system first, so that you can just execute, or you can just write these files and execute these files. So this is how this is the traditional way. So, or you can say phase one before moving on to containerization or using Docker. Okay. So first of all, it's something like this actually hampers the portability over here, because first of all you need to install all these things and then you have to start with it. But what happens is Docker is, it's not like you need to have all these things installed, or in the scenario of containerization you don't need all these things installed, okay, into a onto a system wherein you want to run it. You just okay, you just need Docker installed onto your system wherever you want to run that web application. I will just give a brief justification as to why this particular point over here, and we would be, justifying it later in this session. Then why containers? The second point, it is consistent. Like the developers. Okay, there is a question coming up. Then why we use VM? Okay, so I would be explaining this part also in the later part of the session. Why VM? So over here we were on the second point, which is consistent. Know that developers are working with identical code. So this somewhere down the line, it relates to the version control system that is there before the web application is containerized and it is hosted on AKS or the Kubernetes cluster basically. So there is a kind of consistency, okay, and it also helps in easy rollback in case of anything goes wrong. Then coming on to the question that was prompted over here, that why we use VM. So the upper hand that containers provide is lightweight. It has less disk usage and optimized CPU and memory usage as well. Do we still use VM? Like if containers have already so many advantages of images, I don't know how this works, but everything AKS sounds good. But we can everything with VM, right? Then why AKS? Okay. So now comes an interesting point. Everybody is saying that okay, why to use Kubernetes or why not to use VM? So I will just give a short explanation over that. So now the last point is fast deployment, booting, patching updates. Okay, so these are kind of advantages that you get when you start using containers. First is portability. You don't require all the dependencies to be there onto a system where you want to host the containers, or where you want to use the containers. Then is consistency, and also you have a lightweight kind of thing wherein you use the resources optimize in an optimized manner. Then is efficiency, and I would be just explaining all these things over here. So what happens usually is, like if I just give a justification for the VM, like why we are not using VM or why VMs are not so optimized. So what happens is that if you are using VM, let's say that you just spinned up a VM on Azure, which is having 2 GB of your RAM, and then you use let's say 135 GB, which is the minimum if you go for a Linux VM. Okay, and let's say you use a 2 core machine. Okay, this is your compute. Now exactly what happens is that your ultimate goal is to host a small Python application on to any platform. Okay, that is your ultimate goal, that okay, my Python application, or sorry, my Python web application should be up and running, and if somebody visits my domain, which is let's say pythonapp.com, he or she should be able to see my website. Okay, so you just need any platform for running, or you can say hosting your web application. So in this scenario, it is, let's say, just a kind of website which has hello world written on it. Okay, but do you think it's legit to use a 2 GB memory, 135 GB of hard disk, and 2 core machine just for a kind of hello world application. Share your comments. Do you think that it's worth spinning up this machine and paying let's say around 3,000 or 4,000 for this machine on monthly basis? Is it legit? Is it worth? No. Okay. Okay. Prompts are coming as no. So you are right over here, because you know what happens over here is like you have so much of compute available and you are just hosting a small website which does not require these many resources, right? So what happens in case of containerization over here, or when we just use AKS, or even if you use Docker onto a system over here, if I talk about AKS, you have some kind of privileges to specify that okay, container, or it's a deployment that I would be explaining it further, should use let's say only 500 MB of memory, which is RAM. And then you just have to specify the image, or you just have to give your image, and your image already has those files, okay, your web application files. So you and then you also can specify something like okay, this should not use more than 0.5 core of my CPU, which is compute. Okay, so this actually contributes in optimizing the use of your resources. Okay, so rather than just using a kind of two core machine with 2 GB RAM, 135 GB of hard disk, which is the minimum you can spin up, which will actually cost you 3,000 to 4,000, which is not worth for a single small application over here. So what you can do is over here, you can just deploy your application onto the AKS, or you can just deploy your application or host your application using Docker, and you can specify all these things like I just want my application to use 500 MB of memory, or just 0.5 core of the machine. Okay, so that actually contributes to optimization, and rest of the compute which is available you can dedicate it to the other applications, right? So this is one advantage over here. And the second advantage is about dependencies and also for deployment. Okay, so there might be scenarios wherein you let's say in case of Python, there is something called as request over here. Okay, there is some module request which is required by your web application, and it has some kind of requirement that it should only use let's say version 1.1. And then you can't just keep on upgrading the dependencies onto your local system, because ultimately you have to focus on enhancing your web applications rather than enhancing, or rather than installing all these dependencies. Okay, because if you keep installing dependencies, whatever required dependencies, then when will you just enhance your web application? When will you add features onto it, right? So this is a second advantage over here, wherein you don't have to struggle for dependencies. You have everything bundled up in an image that we would be seeing further in this session. So this becomes your second advantage. The third advantage is about deployment. Okay, so what happens is usually you just just write something onto your directly onto your production, and you just save your file. And if the file is let's say it's not valid, so what happens is like your whole website goes down. But this is not the scenario if you use AKS, or if you use some kind of containerization. You have images over here. You have images like you have some tag as v1, you have some tag as v2. let's say that v1 is the stable version over here, and then you made some changes and then you deployed a v2 image, which is the version 2 image, and you found out that okay, this v2 image is not working fine, or my website has gone down because of this, then you can easily roll back to v1 over here. So in case of deployment, if anything gets messed up, you can just go to the previous version and you can just roll back to it, and your website is up and running. Okay, and there are lots of more advantages that we are going to cover in this session. Okay, anybody has any doubts till now can directly post in the comments, and I would be addressing the same before we move ahead to the next slide. Okay, not yet. Okay, so I will just move on to my next slide, which is basically explaining the complete structure of containers over here. So what happens is that you have your VMs. Okay, what we were discussing right now, you have your VMs over here. Okay, and these VMs are basically your applications which are hosted on your operating system. Okay, this operating system could be Linux, could be Windows, could be anything. Okay, but uh, what happens exactly behind the curtains is that you are having your hardware. Okay, let's assume that you are just trying to host a kind of portfolio website onto your local system, onto your personal system. So you would be using your own hardware. Let's say you are having 4 GB of RAM onto your system, you are having 1 TB of hard disk, and you are having, let's say, 6 cores of CPU. So this becomes your server hardware, and then on the top of it you are having your host operating system, then you are having some kind of hypervisor. On top of it you are having your operating system, then you are having your apps, and then you are having your VMs over here. Okay, so basically this contain this particular structure what I am talking about is that for a VM. Okay, so what happens behind the curtains is like you are having some kind of virtualization platform over here, which helps you to have multiple you can say multiple VMs hosted on a single stack of hardware over here. Okay, so what happens in case of if I just give you a brief overview of how the on-prem data centers work. So you have some stacks of RAMs, some stack of let's say CPU components, some stack of hard disk components. Okay, so on top of it you have something called as hypervisor, and there are a lot of more components. Okay, and you can just assume that on top of it you have your some kind of virtualization platform, and then you have your VMs. Okay, and these VMs are what you can just access over here, and you don't have anything, or you don't have that particular access to just modify anything over here. As modify as in you cannot change like, okay, this RAM is not working fine, I should move to second RAM, or this hard disk is not able to cope up with some kind of copy speed, or something of that sort, like a read and write speed, I should move on to second hard disk. So you don't have the capability for that, you just have the privilege, or you just have the access to use these VMs which are hosted on this server hardware. So this is the structure of the VMs, or you can say the traditional way how the applications were being used, or how they are being used right now for some of the organizations. Okay, so this is the structure of your virtual machines. But if I talk about containerization, so this is how your containers are, or this is how the structures of containers are. You have your hardware over here. Okay, the same hardware that you are using for your VMs. You have your host operating system as well, but instead of utilizing the complete hardware over here for your virtual machines, what we are doing is we are having a kind of runtime over here which is called as container engine. So you have, if you talk about container engine, you have your Docker, you have Cryo, you have Podman, you have Rocket, you have multiple container engines available, or multiple container runtimes available, and you have then your applications running on containers over here. So this is basically to make you understand that okay, you are not using the complete server hardware, you are optimizing on your resources, and you are having some kind of runtimes which can just have the containers over here. I hope it is clear till now. If you are having any doubts, you can just post your queries. Okay, somebody is writing yes. Any queries in understanding the structures? Basically, this is what is there for the VMs over here. You have your server hardware, you have hypervisor, you have multiple virtualization platforms over here, and then on the top of it you have your VMs, and you host your applications onto the operating systems of those VMs. And over here you have your container engine over here. Let's say you are having Windows over here, then you have your container engine over here, and then upon that, or on the top of that container engine, you have your containers running, which are basically hosting your applications. I hope this is clear for everyone so that we can move ahead, or if anybody has any queries they can just post it. Okay, I guess there are no queries, so I will just move to the next slide. So now talking about Docker containers and development. So as we were discussing about the container engine, so there are multiple container engines or container runtimes available. Okay, and Kubernetes was the one which was using Docker as its container runtime, but now it has been deprecated. It is using container D, and I guess Podman was also used in Kubernetes previously. So uh, this is we would be discussing about Docker, which is the famous famous container runtime. So why this particular Docker, or why any container runtime? So we would be discussing about that particular part. So as I told you that it is a kind of containerization platform, okay, and it is a kind of common tool set and packaging model for the deployment mechanism. Now what we understand from here is like, if you are having your own organization, you have multiple teams over here. Let's say this is a security team, this is the infra team, and then you have your development team. So there would be multiple teams in onto your organization. Okay, so for different teams it is a common tool set that you are using. Okay, so every team, or you can say every business unit, would be developing their web applications, okay, or any kind of applications, but the common tool set that we would be used that would be used into every business unit would be Docker. Okay, so once you use Docker and you have a common tool set, so there is no such thing like, okay, you raise tickets for with somebody who is expert, who is having kind of expertise on a particular framework, or a particular way of deploying your web application. So that particular thing is eliminated once you are having something common across all the business units. Okay, or you can say across all the the verticals that you are having in your organization. Then it is a kind of packaging model. As I explained right now, your complete web application along with the dependencies is getting packaged into one single image. Okay, so you don't have to manage, you don't have to run after, let's say one file is with person A into your organization, and second file is with let's say person B, and you require the file with person C as well. So you just need to gather all these files, and then you have to think over, okay, I have to deploy, I will deploy it today, I will deploy it tomorrow. Once the dependencies are being declared by these three persons. So all these kind of traditional ways are eliminated once you move towards containerization, wherein you have your all files, you just have your dependencies, and you have one single image ready with you. You just have to deploy this particular image. Okay, so all these the time which has been wasted in coordination or accumulating all the files and the dependencies, all these things is eliminated to a certain extent. And it actually makes your deployment mechanism more efficient. Then we have something like okay, it actually simplifies, which I right now explained, that it actually simplifies the containerization, because I told you are having multiple ways of containerize your application. So Docker is one of those platforms which actually simplifies your containerization and the distribution of application. Here it means hosting applications for your clients, or you can say delivering your projects. It is this is what is meant by distribution of applications over here. And it can run anywhere as I just explained in the first slide. It's about its portability, that it can run anywhere provided it has kind of container engine running, and you can just host your platforms onto that container engine. Then Docker image can be created and deploy across any environment in seconds. This is what you can relate like okay, it can be deployed across any environment. So let's say that I have created an image which is v1 image, and I have deployed it to, just let me switch to my okay. So let's say that if I'm having an image which is tagged as v1, okay, you can just interpret this image as your web application as of now, with all the dependencies over here. And I just deployed it to one of the environment. So basically what happens in your organization, in any organization, it's like you are having a kind of dev environment, then you have your u8, and then you have your prod. Okay, so first the application that you have developed is being pushed onto your dev environment. Okay, and then you check, okay, this particular feature, whatever I have developed, or whatever the development team has developed, is working fine. Okay, is working as desired. Then you move this particular image. If it's working fine, then you move the same image to UAT, and then you do some kind of testing over it. Like you have your uh, kind of performance testing, and a lot of more testing is being performed in this UAT environment, and then everything is fine. Then you move this image to your prod. Okay, so these are basically three different environments, wherein the slide what it was trying to explain was about this, like it can deploy across any environment in seconds. Like you have your image ready, you don't require anything else, you just refer, or you just point your environment to host your application by just giving the image URL, or you can say the image name along with its tag. So this is how you can just deploy your image into any environment in a matter of seconds. Then okay, it is saying about Docker Hub that it is a kind of you can say a kind of gallery. um, if you correlate it, like you have your images into your gallery, which is basically being stored into your memory card or into your phone memory. In a similar manner, you have your multiple images, and the gallery is nothing but your Docker Hub, or you can say any container registry. And they have their own storage system on which they store your images. I hope this correlation is clear. If anybody has any okay, there are so many commands in Docker. You don't have to. I'm not able to recognize them all. Okay, so it's like yes, I also agree that there are a lot of commands in Docker. There are a lot of command for using Kubernetes. You have your kubectl over there for just maintaining all the pods or the deployments. But yes, you don't have to remember all of them. Okay, you can use the cheat sheet which are available. And over the time, once you work with Docker, or once you work with Kubernetes day in day out, you will start remembering all those commands. and they are logical as well. There is nothing like there is rocket science over there. Whatever task you want to perform, accordingly you have kind of tool list for Docker and also for your kubectl. Then okay, it is organized as open container initiative. Okay, you can just consider this as it's a kind of open source platform which you can easily use, and you can just try out things. Now coming on to your queries, like okay, there are lots of commands and it's difficult to remember. Okay, I just want to but what if where we can use Docker? We don't have any such project where I need Docker or Kubernetes. Web hosting is enough for us. Can you guide me where I can practice? Okay, sure. I will just guide you through that particular part as well. Uh, so as a beginner, what I would suggest is that you need to be familiar with these three commands. You don't have to remember all those commands which are available or which you see in every other YouTube videos. So as a beginner, as a fresher, you just need to have knowledge, or you just need to remember these three commands, which is docker build, docker pull, and docker run. Okay, so what happens over here is that initially, as I told, the phase one, or you can say the first thing that you have to do is you have to build a image. You have to create an image. This is your first part, or you can say the first phase for containerization of your web application. Then this creates your image. Okay, and then it's like because your second phase would be pushing your image. Okay, so there would be docker push over here. And for example, you already have your image created, then the third step would be pulling your image. If you already have an image onto your container registry, then you have to pull it, or if you don't have anything, you have to push it. Okay, it's push and pull over here. And once you have either pulled it or you just have pushed it, you have your image onto your local system. Then you just have to run that particular docker image. I will just explain it over here for a better clarity. Okay, so your first and foremost task is to create an image. Then your second task is to push this image. Okay, because if you are not pushing your image, okay, push image to some kind of container registry. If you don't push your image, then it's something like you are having some files, but these files are only with you. Nobody else is having the access to it, or nobody else is having that particular file. So to make it globally available, or to make it available for other members of your team or other business units, you need to push this file to a content registry, which would be a kind of common platform for storing your images. Okay, this content registry would be storing your images. And the third step, this third step would be either performed by any of your colleague within your team, who would be just pulling the same image. Okay, because you have pushed the image and this particular person has not created the image, that person would be just pulling that image. I hope this push and pull is crystal clear for you all. Like, you're pushing the image, then anybody who requires that image would be pulling that image. Are you all clear? Just give me a heads up on this chat. I'm waiting for your comments. Okay, clear. Okay, so then what happens is that once you follow these three levels, okay, this thing is optional. Okay, you don't need to perform this until unless you want to pull image which has been pushed by somebody else. Then the final thing is about running that image. Okay, so you would be having some query in your mind, like, okay, where is the container over here? So what happens is that you are having your image, and once you execute this runtime, it becomes a process, and that particular process is called as container or containers. Just like you have your some kind of you can say, okay, you are having your web server, if you are aware about web server. So that web server is basically a kind of you can say okay, it would be some kind of file with some extension. Okay, some extension, and it is just a file unless you don't execute this file. All right, so once you execute this file, this actually becomes a kind of service onto your local system. And once it becomes a service, you are able to just browse through your website on port 80 or port 443. It is a kind of similar process over here, wherein it's just an image, or you can say it's just a file for your understanding. And if you don't execute this particular file, it is just a file. And once you execute this image, it becomes a kind of process, which we call as containers. And you can say, okay, this service is you can just relate it with containers, wherein if you just browse through its IP address or its host name on port 80 or 443, you will be able to see your websites. I hope this particular correlation of image, like what is image, what is containers, and why we call this as image, why we call this as containers, is clear for you all. Give me a heads up in the chat. Come on, guys, be interactive. I want your comments in the chat. Can you show us how we will do? Yes, sir. We can be hands on for this. Okay, sure. I would be moving towards that as well. Some kind of hands on, but I want the you guys should be able to understand the theoretical part of it first, like how these things work and what is happening behind the curtain, so that when we go yeah, and perform some kind of hands on, so you don't have any kind of difficulties over there. Okay, so I hope this is clear for you all. I will be moving to my slides over here. Okay. So then, the next point is about microservices and containers over here. Okay. So this is a kind of high level overview, which will give you a justification as to what was there previously, or what organizations were using previously. A kind of monolithic approach, wherein you can say that there were multiple applications. Which were running on the, you can say, the same server hardware. Okay, and it was becoming very much difficult for them to maintain it, because there were kind of instances wherein they tried to just modify this application one, but there were multiple applications on the same hardware. They ended up messing up with application second, or the third application. Or you can say, you I will just explain you it in this manner. Like what happens in monolithic application is, like, you are having this whole block over here. Just a minute. So you are having this single block over here, and within your single block you are having your login page, you are having your sign up page, you are having your payment gateway, and you are having all your features in this single box. So what was happening is that this particular login page was, let's say, dependent or integrated with sign up page. So if you try to do something with the login page, or you try to do something with the sign up page, and as sign up page was correlated or somewhere integrated with the login page, something if goes wrong with the sign up feature, the login feature was also not working. So everything was tightly coupled over there. If feature A goes down, feature B or feature C will also go down. This was a kind of scenario, and everything was hosted on one single environment, or you can say one single hardware. Okay, so what was happening is that if hardware uh, goes down, if this hardware goes down, the complete web application, which was also called as monolithic application, goes down. Okay, so it's a kind of single point of failure, you can say, SPF, which was happening in or which is currently happening if anybody has a monolithic application. So these are the risks when you have something like a kind of monolithic approach for your web application. But if you talk about microservices application, you have your different features. Okay, you have let's say you have your login page, you have your sign up page, you have, let's say, if you talk about Facebook or Instagram, you have a kind of service for like, you have something for comment or for share, and for each of these features you are having individual containers. Okay, and individual containers over here also kind of improves or tries to overcome over this particular thing, which is SPF. And I will just explain you how it overcomes this SPF. And this particular SPF is a kind of risk in monolithic application, which I explained you right now. And there is one more thing over here. If we just correlate this colors over here, you know so if you just remember this for a second or two, I will just explain you how this particular thing is there. So over here, let's say you are having three or four services. Let's say it's for like, it's for comment, this is for share, and this is let's say for downloading it. Okay, and you are having two applications, like one is Instagram, one is Facebook. And if you are having individual services, which is also microservices for every other feature, there are chances that you may be able to, if you have some kind of customizations into your microservice, you can even make it a kind of reusable service. Like if there is a like service in Instagram and there is a like service in Facebook as well, you can just use the same container with some kind of customization, and you can use the same source code for Instagram and for Facebook as well. The same goes for the comment feature as well. You can use it for Instagram and you can use it for Facebook as well. So this is advantage number one. There are lots of advantages, but I would be just covering the advantages which you can correlate. The second thing is, like in monolithic, as I told, that as it is being hosted on a single hardware, or you can say on a single system, there are chances of single point of failure, wherein if this particular thing goes down, your whole monolithic application goes down. But if you talk about Kubernetes, here I am just giving you a introduction about Kubernetes. Earlier we just saw about Docker. In Docker, we just saw that we can just execute that one single image into a container, and there would be one single container running. Okay, and I will just go through this slide first. I think then you guys would be able to correlate this part. Okay, so you have multiple services for hosting your container. Okay, so what we talked earlier was Docker, which was a platform. Okay, and for just creating your image or running your image individually, not in orchestration. I will just explain you what is orchestration after this slide. So here are the services, like if you want to eat vada pav, for example, you have multiple stalls. If you go to any kind of food market, or any you can say a mall basically, so you have a variety of options. If you want to have burgers, right, you have McDonald's, you have KFC, you have Domino's, so you have variety of options over here. You have to choose, like, okay, uh, which restaurant or which food stall I have to go and I have to purchase the burger, right? So that in that particular manner only, you have multiple offerings within Azure for hosting containers. Okay, you have your Azure container instances, you have your Kubernetes, you have your okay, registry uh, is the basic component over here. Okay, you can just ignore this as of now. Then you have Azure Service Fabric also. So you can say that Azure container instances is offering you a burger for 130. The same thing is being offered by Kubernetes for 150. The same thing is offered by Azure Fabric for 200 rupees. So according to the requirements that you have to choose any of the service for running your containers in a similar manner, that according to your requirement, like how much hungry you are, or how much you want to you want to expense on this particular burger. Accordingly, you just go to the respective food stall. So I hope this correlation is clear for you. If you are having any queries, you can just post in the chat. I'm just trying to correlate it with real life, so that you guys are able to interpret it and understand it in a better manner. Guys, be interactive. I want some comments in the chat box. Just let me know if you have not understood anything till here, or if you have not understood this part. Okay. Azure Service Fabric use cases. So as of now, I won't be deep diving into Azure Service Fabric, but you can say that it's a kind of similar service on which you can just run your containers. Okay, there are multiple use cases. You can just go to Microsoft Documents and you can just explore those. But as of now, I would be just limiting my presentation or the session with AKS and ACR, but you can very well explore these services as well. Okay, what is the difference between AKS and Azure Service Mesh? Srinivas, it's a good question, but this would be too complicated for other audience over here. You can just connect me on LinkedIn, and I would be definitely glad to explain you those concerns about service mesh and Kubernetes, or how we use service mesh in Kubernetes, Istio. You have something those technologies which are being used for better infra. So anything apart from that related to ACR or AKS or whatever I've explained so far? Okay, great. So now we have Docker container registries. Basically, I just told you to ignore this point over here, container registry, because I wanted to cover it in a bit depth in this slide. So basically, once you have covered your step one of creating an image, you have to store it somewhere, right? So for storing the same image, you have multiple options with you. Like, you have multiple container registries available with you. You can either use the Docker container registry, or for Red Hat you have a kind of registry called as QA, which is this one. You can use this one, or you have your content registry by Azure, which is ACR. Okay, and then you can just create your private ACR as well. Basically you have two varieties of ACR. You have your public ACR, then you also have your private ACR. Okay, and also there is one more thing, if you are getting confused with this mcr.microsoft.com. So what happens exactly is that for every application, okay, just let me switch to this one. Yeah, so what happens is that if you are let's say using Google, and Google is using containers behind it, so they are having their own container registry for their application. Okay, so there is container registry for application. So even if you start your own web application and it becomes very much famous, then you maintain its versions. Okay, with every new version you add some features or you improvise your services. And in a similar manner, for let's say for Microsoft, if you want to use a kind of container which uses, let's say, Windows 2019 operating system, so you will be getting that particular image, or that particular that particular container image into the Microsoft container registry. So each and every organization which is using some kind of containerization or is hosting their Docker app, Docker image, is using some kind of container registry behind the curtains. So for getting Windows images, you have your Microsoft Content Registry, wherein they have all the Windows images out there. So I hope this Content Registry thing is also clear with you all. Guys, please post your comments. Can you share your slides? Okay, I would be sharing my slides. Okay. Okay, now we would be moving to something hands-on over here. Um, as the title of this session goes, like we would be doing something related to Azure Content Registry and AKS. So I will just show you how you can create your own content registry on Azure, and then we would be moving on, to these things. Okay. Okay. So, okay, this is okay. Yeah, I hope my screen is visible. Okay, so this is your Azure portal. I have already spinned up AKS over here just to avoid any kind of time wastage over here, because it takes approximately like 10 to 15 minutes to spin up. But I would be doing ACR over here simultaneously. So first of all, this is your Azure dashboard. Once you sign up for it, or once you log into Azure portal, this is a kind of dashboard that you would be getting. And yesterday I explained, a kind of hierarchy that it follows. So you have your tenant, you have your subscription, then you have your resource group, and then you have your resources. So I will just quickly click on create resource over here, and create resource, as in, you can just use any of the Azure services over here, and that service becomes your resource. So I would be I'm just giving it as content registry, and I got a prompt for that. So it's loading, and yeah. So now, as you can see, there are multiple options available over here for content registry. You have your something for you have something like JFrog, which is used for storing the artifacts. Then multiple relevant options are being displayed over here, or you can say something which has a keyword container has been displayed over here, because these are all something like OpenShift is something which you have on top of Kubernetes, or which is used to manage Kubernetes. Then you have multiple things. You have your web applications on which you can host your containers. So you are having some relevant options or some services which is having containers in their name. But we would be selecting the first one, which is Microsoft Content Registry or Azure Content Registry or ACR, what we call. And then this is a usual thing that you get while creating any resource. You have a kind of form over here which is to be filled up. So this is a subscription, and inside the subscription, as I told you, following the hierarchy, I will have to select a resource group. For me, this is a resource group which I have already created. Otherwise, you can just create a new resource group. Then for identification purposes, like you also have some kind of name. Somebody might be having a name Rohan, my name is Mubin. So it's a kind of identification that you are able to do with the name, right? So in a similar manner over here also, you have to name your resources. So whenever you want to search or you want to do some kind of modifications onto your resources, you have your name. You can just search for the name, and you can just go to the resource and you can just do whatever modifications which are required. So now I would be giving this name as ACR. Okay, it's alphanumeric ACR demo 1. Let's see if it's available. Okay, it's already there. ACR demo Kubernetes. Okay, this is available. Then you have your locations over here. Now the main use of this location is like if I just explain you this part also, it would be clear for you. uh, let's say that you are having your containerization platform or orchestration platform AKS in central India, and you are having your ACR, let's say, in West Europe. So what happens is that whenever you try to pull any image, like AKS is trying to pull any image from the ACR, which is located at a distant location, like it is far away location basically. So it will take some time for the AKS to pull your image from the ACR, which is located into completely different region, or you can say this is in central India, this is in West India. So this particular thing, when you don't keep your two resources which are going to be used simultaneously or are interdependent close to each other, then it introduces some kind of latency over here. So that is basically the primary use case of keeping interdependent resources or services into the same location or nearby location. Otherwise you have some kind of compliance factors as well, which uh, on the basis of which you have to decide the location for deploying your resources. Then you have your availability zones, that is basically for making your resource more available or highly available, so that if one availability zone goes down, you have your resource up and running from the next availability zone. So I don't have the use case, or I don't have any kind of usage for availability zone, so I won't be enabling it. Then you have different SKUs. So depending upon your use case, whether you want to go with standard, basic, or premium, like every other SKU has something, like standard would be offering some less features than premium, the basic would be offering less features than standard. So according to the requirement, after exploring through the features which are being offered by individual SKUs, you can select an appropriate SKU. As of now, I would be going with the standard one. Okay, then you have your connectivity. So what happens is that if there is some kind of confidential container or confidential information into your application, and you don't want that okay everybody would be able to access it publicly, then you also have an option of private access. Okay, so what happens is, I will just explain you this part as well. So what happens is that you are having your ACR, and your ACR is having some kind of URL. Just now we use something like ACR demo Kubernetes, so it will be having some kind of URL generated. And this particular ACR, if we keep it as private ACR, so then what will happen is that only the network which is connected to this ACR would be able to pull the images from this ACR. And if you are using public access right now, then anybody across the globe would be able to pull your images. There won't be any kind of restriction. Okay, so if you want to understand it more, there is this service which is called as VNet, and you are having your subnets. So basically, you can correlate it as you are college students. I would use this example. This VNet, or the virtual network, uh, is nothing but your campus, your college campus. Okay, and you are having different classrooms over here. Okay, let's say this is classroom for FE students, and this is classroom for B students. Okay, and within the classroom you have your seats. Okay, you have multiple seats into your classroom. Now this is your complete campus, which is VNet, and you can assume this classrooms as your subnets, which is a part of your campus, but you can say yeah, as a part of your campus, but uh, it is something related to sitting. Okay, you have your sitting over here. You might be having audio visual rooms, you might be having your staff room, you might be having several other things within your campus. Okay, but for sitting purposes you have your classroom over here. Okay, and for networking with you have your seats. Okay, you can understand it in this particular manner. And what you can assume over here is, like, your seats are nothing but you know the resources on your Azure. Your resources on your Azure are connected with your network, because if you are not having any component associated with your network, then how would you just access those components from your personal system? There has to be some kind of network associated with those resources to access or to do something on the top of those resources. You can understand it in this particular manner. Now as these resources are nothing but the seats of your classrooms, and you very well know that in your campus you have some entrance gate over here, and there might be security guards who would be checking the ID cards of the students, and then they would be further granting them the access to then appropriate classroom. Okay, or you guys would be going into the class into your respective classroom, then sitting over there for your lectures. So in a similar manner, what happens is that if you talk about this particular thing of private ACR and your public ACR, so this particular ACR is nothing but a seat over here into your campus, and your campus is a kind of VNet, and only the students of this particular campus are allowed to go inside it and to sit here for the lectures. So in a similar manner, only the resources which are there in this particular VNet or the subnet would be having the privilege to access this ACR. I hope this correlation is easily understandable by you guys. If you have any queries understand this correlation, you can just comment in the chat box. Okay, there are no questions. I hope you are able to understand, because I am just using real life examples over here to make you understand the complicated architecture, or the complicated things over here. So this is, I am just reiterating once for those who have not understood. This is your campus, which is nothing but a VNet, virtual network, and then you are having your subnets. So these subnets are nothing but your classrooms, and the seats inside these classrooms are nothing but your resources. Okay, and you guys are students, and over here in Azure it's resources. Okay, so you being a student of college A, which is for this particular campus, you can only go and sit over here, right? Nobody else who is not having the ID card can go and sit for the lectures in your college, right? So in a similar manner, only the resources who are having the privilege or who are there in this subnet can access the resources into, the other subnet or resources across this vnet. I hope now it's very much clear for you guys. So now, okay, this is for, so this is what I was explaining over here with respect to your public access for your ACR and private access for your ACR. So uh, the resources only within the same network would be having the privilege for private access, and you are restricting the public access thereby. And if you are having public access, you are just making it open for all. So we would be using public access over here. Then you have something for encryption, and as you remember that, as I told you in the basic sections over here, that if you are having something like some SKU, like the standard SKU, it would not have that many features which are being offered by premium SKU. And if you talk about basic SKU, it won't be offering the features which are offered by the standard SKU. So over here, it is easily relatable that this feature is only available in the premium SKU. But as we have just selected the standard SKU, we won't be having the privilege to have some kind of encryption. Neither we would be having the privilege to have the private access, because all these features are available in the premium SKU. Then you have tags. This is again, for better identification. Like if you are having one single environment, let's say for your project, and accordingly there are multiple projects within your tenant or subscription. Just to identify your resources, you can have appropriate tag over here. Let's say, like if you are having project, let's say based on AI. So, and you have your student name, let's say Rohan. So these tags are basically for easy identification. So whenever you want to search something, and you just have a filter option over there, and you just go to the filter option and you select that, okay, I want to filter out all the resources which are having this tag, which is project, and then the value is AI Rohan. It will just list all the resources with that particular tag. So it is basically for easy identification, or you can say easy access to the resources with particular tags. So yeah, this ACR is basically provisioning. Meanwhile, we will just move and move towards the slide and see what's there in it. So it has a similar thing, similar content over here as well. That it's a kind of private registry for hosting container images, but as we saw, it's only a kind of option that you get for enabling the private registry. But as of now, we are using the public registry. Then you can okay, you can just orchestrate those containers that we would be seeing. And what else is there? You can store and manage container images, which this is what we already saw. It can store and manage container images. And you should be familiar with this Docker command line. This is basically there as a prerequisite, so that you can just push your images. And as I just covered right now, that you can just keep container images near deployments to reduce latency and cost. So this is the same thing which is explained over here, that if you are keeping your deployment resource, which is nothing but AKS, in central India, then you have to keep it, you have to keep the ACR basically also in central India, so that there is less latency. And with latency, there also comes some kind of cost, that is the bandwidth cost. And okay, there is some kind of access management. So again, going back to the campus example, that if you are having some kind of labs within your campus, let's say, sorry, if you are having some kind of labs for your computer department, department, then you are having some kind of labs for your mechanical department. So at the entrance of that, you would be having some kind of access control, that okay, only the students having a valid identity proof, or you can say valid ID card, which states that they are from the comms department, then they would be able to access the labs of the comms department. And the same goes for the mechanical department. In a similar manner, you have some kind of access control when you talk about the resources on Azure. Let's say if I am a kind of project lead, I would be getting an appropriate permission. If I am the team lead or the technical lead, I would be getting the relevant permissions. So this is about the access management. It should not be too complex, and it should not be too simple that anybody could just privilege their access control and access whatever they want. And then you have maintain Windows and Linux container images into a single Docker registry. So I would be explaining it further. So that was about this particular slide. Then we go to the second slide. Okay, this slide, this is about the Docker file, which I would be explaining right now. Okay, somebody saying, can you please share the link? Okay, Lakshit, I guess you already have the repo link. Somebody's asking yesterday's repo link. So please share that.
Sure, I will.
Yeah, okay. So now we are coming to something which is called as Docker file, which is basically used to create the images. So yeah, this is my machine. Switch it. Okay. So I am using let me clear this one. Okay, so I am using VS Code over here as a ID, or you can say a kind of uh, platform to just write my Docker files over here. Okay, and again, as I explained yesterday, that for every technology that you are working on, you have your relevant extensions over here. Okay, so with those relevant extensions, you can just enhance the development over here. Whatever you are working on with those kind of assistants, as you guys were kind of requesting or asking for some kind of solution to remember the command lines, or to remember some kind of syntax. So this particular extensions are there available to help you in those particular scenarios wherein you are a kind of fresher, you are not having or you're not remembering those command lines or syntaxes. So those extensions will assist you in that particular scenario. So now come to a kind of very interesting part, a kind of hands-on part of the session, wherein we ourselves would be developing Docker images, and we would be understanding how these Docker images work. Okay, so okay. Okay, so this is basically Docker image, a sample Docker image or a Docker file that we are having right now. And if I just I don't know whether, okay, this pencil is not working over here. Okay, so just okay, so we are having basically these keywords over here, you can say. Okay, and as I just hovered over here, you saw there were some suggestions which were coming up, right? This is because I have my extension installed over here. Okay, so it is, these extensions also help you to understand that okay, this from keyword is for what exactly. Okay, although I have added a comment over here for your understanding, but this also helps you, the extension basically helps you to understand this part. This is a base image over here. Okay, base image is you can say it's nothing but a kind of operating system, or you can say lightweight operating system. Lightweight operating system. Okay, lightweight operating system with dependencies, or you can say with least dependencies. Okay, So I hope you got this point over here, which is the base image. Like I just explained you in the initial phase of this session that whenever you are deploying some kind of application using a VM, you just utilize your whole operating system. Let's say Windows, you have multiple things which are not required for an application, right? And you are just wasting your resources by having those particular applications or services on top of your virtual machine. But over here, you have multiple base images. Okay, for example, if you want to go with Nginx, or you want to go with Apache, or you have your web server for Apache, so you can just download that relevant base image, which is nothing but a kind of operating system. And just having that operating system, which is lightweight, which is not in GBs, you just have it in MBs, and you can just have your application hosted on the top of it. Okay, so I would just give a small justification over here as to why this particular thing is very much fast. Okay, before that, I just want to know that if you want to just install Windows operating system onto your system, how much time does it take? Has anybody experienced installing Windows operating system freshly onto your personal system? I just want to know the amount of time which it takes. Anybody who has installed Ubuntu operating system onto the systems can just comment down like approximately how much time did it took for them to install it completely. I use Ubuntu from 3 years. Okay, that's fine. But I just want to know that how much time did it take for you to install that operating system? Okay, somebody is using Kali Linux. Okay, that's great. Any comments regarding that amount of time? So usually, if you are having some kind of SSD hard disk, so it takes somewhere around 10 to 15 minutes, or maybe even less than that. Or if you are using a hard disk, the normal one, which is HDD, it might take up to 1 hour or 2 hour. But in case of Docker, you will just see how much time it takes. Uh, just give name as sample container, and I am specifying the image over here, which is Ubuntu latest. Okay, so it is pulling the image for me, and you saw it is pulling from an appropriate content registry, which I explained you, push and pull, if you remember. So it is just downloading the image, and within a fraction of second, I have my Ubuntu machine up and running. Okay, if I just use this one. Okay, so name is sample container, and if I just execute a terminal over here for this one, yeah. So if you just see, I have my container running, and this is a CLI. Okay, I have this LS running. I have a whole operating system which is spinned up within a fraction of a second. This is what my slide was trying to explain, like how fast it is. Okay, if you just go and install some kind of operating system onto your personal system, or even if you spin up a VM in that matter, it might take 5 minutes or 6 minutes to get that particular VM provision, or even an hour or two for the operating system to get installed. But over here, you just acknowledge the fact that the Docker just took a fraction of second, or a single minute, to just get my operating system, the Ubuntu operating system, up and running. And I have the complete system over here. You can see the file system over here. If I just go to if I just try to install something over here, let's say, okay, it's Apache 2 in Ubuntu. Just have to run Get update over here, and you're seeing that I'm able to perform, like any command that you perform onto your system, I'm able to perform that commands on this container which is running. I hope this was interesting for you. If you have any doubts till now, just paste that in the chat. I'm just trying to install a kind of Apache web server meanwhile. Guys, be interactive. I want some comments from your end as well. Sir, I'm getting log errors. Uh, where exactly you are getting log errors? Saying directory not visible. Okay. So, I will just help you to understand that first. So what happens over here, just ignore this as of now. So over here, I will just explain you this thing, so it might help you to solve the errors. So over here, you are specifying the base image, okay? And after uh, specifying the base image over here, you have to set the working directory. So can we run this script in PowerShell to why only bash? Okay, so what happens is I will just clear out this part, then I will move to that query. So over here, you have your working directory, which means that whatever we want to perform within this particular Docker image would be performed keeping or considering that this is the home directory or the working directory basically, and all of your files would be whatever files you are creating, copying, or you are adding would be directly performed over here in this working directory. So you can say that this working directory basically this where www.html becomes your current directory, and this is for your container, or let's say for your image, this becomes your current directory. Okay, and then what we are doing is we are copying some files, which is this file index.php.html file, into the current directory. This particular symbol that you see is just specifying the current directory. Otherwise, the other option that we have is we just give the exact path over here, like where www.html. We can give this path as well. If there was a scenario wherein we had not declared the working directory, then we would have used this path. But this particular thing, if you are specifying, there are chances that you might just give a wrong directory, or this directory is not available. Then in such scenarios, the process of building the image from the Docker file breaks in between. So that is why, in order to avoid this particular thing, it is recommended that you specify the working directory over it. Then, as I told you, that you have to copy the files, and it is not that you have to copy the HTML file. This copy refers to copying your complete source code, whatever source code that you are having. Let's say okay, the MSI stream will end in 5 minutes. Okay, fine. So this is basically how you just create your Docker file. Okay, and once you create your Docker file, then I will just open another terminal over here. So somebody has had some doubt, like why can't we use PowerShell? So this is how I'm just using PowerShell. I'm not using Bash, and you have to build your image over here. So building the image is you have to use Docker build, then -t for tagging the image, basically naming your image. So let's say I will give it as Apache web server, and then I just have to give one more argument, which is of specifying the Docker file. So this would be Docker file PHP. And as I told you that this particular thing symbolizes that my file is in current directory. So yeah, it is now preparing an image, and now you saw that I have, okay, so now you can see I have created an image and this image is there. Okay, this image is up and running, but still I will rewatch the session. It's really good. Okay, so now you have your Docker image created. Now if you want to run it, then you have this command. This is basically dit, means in a detached mode. I will just use D over here, detached mode, which means that once you run your the container, you won't be getting those error logs which somebody had posted in the query. So in that particular scenario, you have to use -D, okay, detached mode, so that you don't get logs over there, and then you can just go inside the container. I would be showing you that as well. So that is about Docker. Docker run. You have to use it in a detached mode. Okay, then I would be giving, okay, I don't want to give it some name. I would be using some kind of port mapping over here. Attendance, okay. Let's say 85 or 86 is the port on my local system, and it would be basically connecting to the port 80 of my Docker container, and then I would be giving the image at the end. Okay. Okay, it's not running. I guess I have to use Docker dit. From dit, okay, I have to give some name, I guess. Let's say Apache server. This is the port for 86 is to 80. And okay, I had given a wrong image name. That is why it was giving me an error. If you see, it is equal to, but this image is not available. Okay, just a minute. So basically, you have to make sure that you have your image available. It's Apache web server latest, and what I gave over here is, okay, Apache web server latest. So if you don't have to get confused between this name, it's something like you have to run it in detached mode. This is the port mapping which I have done, and this is the image name. So Apache web server. Okay, this is fine. Okay, now you saw you have your container running over here, and if I just quickly go, and if I just use local host, it was 85, I guess. It was something else. Okay, it was 86. Okay. 86. Okay, it's forbidden. So I will just explain you why it's forbidden. For that, we just need to go inside it, for which you have to use Docker execute it, and then this container. Okay, and over here you have to specify which terminal you want to access, and okay, I'll just try to troubleshoot it. Okay, you don't have permission to access, I guess. You have to give some kind of permission to this file, otherwise it won't work. I guess it's the same thing. Mode -R7. Okay, if I now try to do it, okay, it's basically, there is some kind of permission issue over here. That is why it's not www data. Okay, so there is some kind of permission issues. That is why it is not allowing us to browse through it. But I will try one more thing. Index.html. Okay, so now it has worked because it was by default taking index.html, but the name of the file was index-php. So now it's working, and now if you just go to your localhost, you see the content of my website is also running. Now the thing is that this is just running individually. If I just show you, this is just running individually over here. There is one container which is running Apache web server. But if you just want to orchestrate it, or you want to make it more reliable, so in that particular scenario, what you have to do is you have to use AKS over here. Okay, so what AKS does is, like, if even if your container goes down, if you have single container, there might be some scenarios where container goes down. So what AKS basically automatically ensures that this container is up and running every time. Okay, so if your it automatically spins up a next container, let's say container 2, which is using the same image. So that basically of your web application, and thereby it orchestrates it. Due to limitations of time, I was not able to cover the AKS part, but anybody who wants to know more about it can connect with me on LinkedIn. I am available on LinkedIn, and this is my username. It's Mubin Giraj. I will just paste it in the chat.
Yeah, and also like if you will see the registration portal, there also it is also mentioned. We have already given the LinkedIn Mubin, because the stream is just we have a couple of seconds left. So thank you, Mubin. Thank you
Yeah.
for all your incredible demos that you have showed. It was very insightful, and thank you everyone for joining in. Don't forget to mention. Just click on the attendance form link. That is mandatory for you all to fill the attendance form link, just for your certificates. And all in all, I guess I could say thank you, Mubin, for sharing your insights for this hands-on demo. Great hands-on demo. Thank you.
Okay. Yeah. Thanks a lot, everybody.
Thank you,
Take care.
everyone. Thank you, everyone. Bye bye.